In this page, what we have is, these are some of the common questions that you're going to come across. At what height did the object start? Well, at this, when they ask you this, starting point, time equals 0. Basically, you're going to plug in 0 for t. When they ask you when does it reach the maximum height, you're going to find negative b over 2a. What was the maximum height? You're by finding the y value of the vertex, you're going to plug in the negative b over 2a into the function. When did it hit the ground? That's when the height equals 0 again. So you're going to set the function equal to 0, and at this point I recommend that you use the quadratic formula. Alright, we have another example here. A ball is thrown off the top of a building. So now you're standing on the top of a building. The ball is at the top of a building, and that's from where it gets shot into the air. The flight is modeled by this function, and we have 3 terms this time. The square term, so that's your a. Linear term, so that's your b. Constant, so that's your c. So we can write them down here. A equals negative 16, b equals 96, and c equals 112. So we're going to answer the questions graphically first. And once again, you have your parabolic shape. You're kind of noticing that your time is going to be your x-axis. So this is t. And this is your height. So it's going to be h of t. So how tall is the building? Well, when was the ball on top of the building? Well, it was thrown from off the top of the building. So at time equals 0 is when the ball was on top of the building. So you go looking for time equals 0. The height at that point is 112. So the height of the building is 112. When did it reach the maximum height? Well, now you're looking for the vertex. At what time did it hit the maximum height? At 3 seconds. And the next question is what is the maximum height? Well, the maximum height is 256. When did it hit the ground? Well, follow the trajectory. It went up and it's coming back down, and it hits the ground again right here when the height is 0, because ground is considered height of 0. It happens 7 seconds after launching. Okay. So the answer is 7 seconds. So this is learning how to read it graphically. Now we're going to pretend that we don't have the graph, and how would we do it algebraically? How tall is the building? Well, you need to understand that the ball is on top of the building at the beginning. So you need to take t and you need to set it equal to 0. So we're going to plug in 0 for t. And take the function. What is the height when time equals 0? You use your calculator and you get 112. So the height of the building is 112 feet. When did it reach the maximum height? When did it reach the maximum height is going to be negative b over 2a. So we know b is 96, a is negative 16. You calculate and you get 3. So it reached the maximum height at 3 seconds. What was the maximum height? When they ask you for the maximum height, you're going to find the y value of the vertex. You're going to plug in negative b over 2a into the function. So we know what negative b over 2a is. It's 3. So we're trying to find out what the function is when time equals 3 seconds. Plug that into the calculator and you get 256. So that means the height was 256 feet. When did it hit the ground? Well, it hit the ground when the height is equal to 0. The function equals to 0. So you take the function, and we're trying to solve for t. So this is where you would either factor, use either GCF or trinomial, or use the quadratic formula. So we're going to go with the quadratic formula. We know this is your A, this is your B, and this is your C. Okay. So x is equal, in this case, time is equal to negative b plus or minus the square root b squared minus 4ac over 2a. When you type that into the calculator, you get that time equals -1 second and that time equals 7 seconds. Well, the first thing we know is that time can be negative, so we know that answer is not valid. So the only answer that it can be is 7 seconds. Okay. Now, looking at the graph and considering the real-world context of this problem, we need to select the appropriate domain. So once again, domain is this one. Okay. It's time. So when thinking about real life, the ball is on top of the building, it launches into the air, max height, and then it hits the ground. So from time equals 0, remember time can't be negative. Time always starts at 0. We always start counting time from 0. All the way up to time equals 7 seconds. That's the only time that it actually applies for this. It doesn't make sense that the ball is on the ground. The ball is not going to make it on the ground, and time can't be negative, okay? So picking the appropriate domain has to be this one, between 0 and 7.